Okay, so we are on the very last part of the heart of algebra, and for these last two pages we're just going to take some word problems and we're going to be able to write linear equations or inequalities with them and then solve the problems. So there will be a couple like this on your SAT. For the most part, it's just making sure you're setting up your equations correctly, so we'll really look at that. And some problems are just setting up the equations, not even solving with anything. Okay, so let's go ahead and work on these examples. The first one, this is page 28 of the Heart of Algebra. It says, a company manufactures chairs. The company charges their customers a fixed fee of $1,500 for setting up the machines and $25 for each chair produced. Number one, find a model for the cost of purchasing X number of chairs from the company. Okay, so that's going to be our input, is going to be X. And let's just start with the table here. So let's say that we input a number of chairs and then our output's going to be the cost. Okay, let's just start simple. If we were to buy one chair, okay, which is probably not going to happen, especially if you go through this company, but just keeping it simple. It says the company charges $1,500 and then $25 for each chair produced, so it would be plus $25. If we were to buy two chairs, you're still going to be charged the $1,500, okay, and then we would be charged 25 plus 25, or 2 copies of 25. 2 times 25, $50. Okay, 3 chairs, that would be $1,500 plus 25 times 3. 4 chairs would be $1,500 plus 25 times 4. Okay, so to write our cost function, okay, notice this 1,500 isn't going to change. Okay, so we're going to have a 1,500 in here. Also, the 25 isn't changing. The only thing that's changing is this value here. And notice it's the same as the x. So this would be plus 25x. Okay, so this is very similar to something you would have to do on the SAT. Number 2, it says use the model to find the cost of purchasing 800 chairs. Okay, so we want to input 800. Okay, and that'll give us our cost. So 1,500 plus 25 times 800. Okay, so that's our input here. Let's get out the calculator for that. I can't do that one in my head. So 800 times 25 plus 1,500 looks like the cost would be $21,500. Okay, next example. It says a gardener waters his vegetable plot using a drip hose. Water flows slowly from a 1,000-gallon tank through a perforated hose, and during the summer, the garden requires 55 gallons of water per day. Number 1, find a function W that gives the amount of water in the tank X days after it has been filled. Okay, so again, let's start with the, just an X, F of X chart, or they wanted W of X here. X is the number of days. Okay, so let's start again simple with 1 day. Okay, so the tank is full. So when the tank is full, it is 1,000 gallons. And then after 1 day, we lose 55 gallons. Okay, so this water is dripping through this hose. And after 1 day, you're losing 55 gallons. So this would be minus 55. Okay, after 2 days, you start with 1,000, and you would be losing 55 times 2. Yeah, this is gallons of water. After 3 days, you would be losing 55 times 3 gallons. Okay, and we could keep doing this. Okay, so again, you can probably see the pattern here. 1,000 isn't changing, so that's a constant and it'll be like that. The 55 wasn't changing, or negative 55 wasn't changing, so we'll leave that alone. You can see the only number that's changing here is the x, and you could put a 1 here, and that depends on what the x is. Okay, number 2 says use the function W to find the water remaining in the tank after 5 days. Okay, so we want to input 5 days. So this would be W of 5. Okay, so that would be 1,000 minus 55 times 5. Okay, again, I'm going to need to use my calculator for this. So 55 times 5, and then 1,000 minus, I got 275 for that solution. So the answer is 725, and this is in gallons. Okay, so after 5 days, there's just 725 gallons left. Okay, number 3, how many days will it take for the tank to empty? Okay, so we want the tank to be empty, so we want the number of gallons to be W. Okay, and we're solving for days here. So it says how many days? So we're solving for days or X. Okay, so that means I'm just going to write out our function again. The X is an unknown. So if one thing is unknown, we have to know the other thing, which would be this W of X. And that would be how many gallons we have. Okay, which here we want empty, so we have 0 here. Okay, so when the tank is empty, that means we can solve for how many days. I'm just going to bring the 55x over to this side. I'm going to come over here. Divide by 55, which again I'm going to need to use the calculator for that. I got x is approximately 18.18 days. Okay, so this would be about 19 days. So it would take, you would want to round up here, 19 days. Because if you just said 18, the tank wouldn't be completely empty. Okay, number 4 says the gardener prefers to refill the tank when the level has dropped to 200 gallons. How many days will it take for the water level to drop to this level? Okay, so again, I'm going to write out my function. Okay, the question says how many days will it take for the water level to drop to this level. So we want the water level to be 200, and we're solving for x, or the number of days. Okay, I'm going to go ahead and bring the 1,000 over, so subtract 1,000 on both sides. That would give us 8,000 equals negative 55x. Again, I'm going to come over here. Divide by negative 55, you should get about, so let me check that, which it might be equal to, no. Okay, about 14.55 days. Okay, so he would need to refill, I would do 14 or 15 days, depending on if he wants it to get lower than 200 or refill right before it hits 200. Okay, so that's page 28. I believe 29 has 2 more examples. Okay, the example says June wants to score at least 32 points in an ice skating routine. She scores 12 points for each perfect jump and 6 points for each fallen jump. Write an inequality for the number of perfect jumps and fallen jumps she needs to perform to achieve her goal. Okay, so let's answer that first. We have 2 variables here. We have a perfect jump and we have a fallen jump. Okay, so let's just use P for perfect jump and F for fallen jump. Okay, and I'm just going to use a chart here. So P and F, this is an input-output. These are 2 variables here. Okay, just so we can get, and I'm going to put points here, just so we can get a formula wrote out. Okay, so we're going to start simple. Okay, so let's say she gets 1 perfect jump and 2 fallen jumps. Okay, I'm just making these numbers up. How many points would she have? Okay, so she would get 12 points for the perfect jump, and she would get 6 points for the fallen jump, but she had 2 of those. It would be like that. Okay, I'm going to make up another number. Let's say she had 4 perfect jumps and 3 fallen jumps. Okay, so she would get 12 points for each perfect jump. She would get 3 points for each fallen jump. So that's how many total points she would get. And let's do one more just so you can see the pattern. Let's say she got, let's do 5 and 6. So she would get 12 points for each perfect jump plus 6 points for each fallen jump. Okay, so her number of points is equal to, you can see that you have 12 times her perfect jump plus 6 times her fallen jumps. Okay, which you can use different variables here. Okay, and it says June wants to score at least 32 points. Okay, so at least means 32 or more. Okay, so her points, or 12p plus 6x, needs to be greater than or equal to 32. So that is the inequality that June would want to use here. Okay, it says after the first minute, June has fallen on 3 jumps. How many perfect jumps must she have on the remaining routine to achieve her goal? Okay, so we can use this inequality here. She's fallen on 3 jumps. We can go ahead and plug that in. So we have 12p plus 6 times 3 greater than or equal to 32. So this is 12p plus 18 is greater than or equal to 32. Subtract 18 on both sides. We have 12p greater than or equal to 14. Let me check that. Yeah. And then divide by 12. So p needs to be greater than 1.16. Okay, you can't have 1.16 jumps. So she must have 2 perfect jumps to get the score she wants. Okay, a lot of the problems on the SAT is just going to be setting up something like this. So really make sure you understand what I did here. Okay, and then the last one, so this is bottom of page 29. It says Bruno has 5 books overdue at the library. The fine for overdue books is 10 cents a day per book. He remembers that he checked out an astronomy book a week before he checked out 4 novels. If his total fine was $8.70, how long was each book overdue? Okay, this doesn't really have anything to do with linear equations, even though they are linear equations, what we'll set up. This is just really making sure you understand how to break down a word problem. Okay, so let's go ahead and take this sentence by sentence. Okay, it says Bruno has 5 books overdue at the library. Okay, so right now he has 5 books. The fine for overdue books is 10 cents a day per book. So let's just write that down. Okay, so he has the fine is 10 cents, which we'll do as 0.1. Okay, per day, I'm going to use for D for day. And then I'm going to do, let's do times. So this is per day, per book. So I'm also going to put B here. Okay, so if he has 5 books, we would just plug in 5 here. So this would be 50 cents times a day. But this second sentence makes it a little more complicated. So it says he remembers that he checked out an astronomy book a week before he checked out the 4 novels. Okay, so this B here can't be 5, okay, because he didn't check them out all on the same day. Okay, it says if his total fine was $8.70, how long was each book overdue? Okay, so let's go ahead and look at the astronomy book first. Let's just come over here. So the astronomy book was 0.1, okay, and it was a week before. So this would be times 7. This is the fine, okay, because that's 7 days, and it's just 1 book. Okay, it didn't say he had 2 astronomy books. So this would be 70 cents. Okay, so that's just the week before. Okay, so now his total fine is, we have 0.1 times the number of days, okay, which we don't know, times the number of books, which is 5 now, because we can add in the astronomy book. Plus, we also need his 70 cents from that astronomy book. I'm going to put up here a week before. Okay, week before here. Okay, so why did I put 5 here now? Because we already accounted for this week before astronomy book. So what he did was he checked out an astronomy book, and then a week later he checked out 4 more. So totally he has 5 for this amount of time. Okay, but he's already paid 70 cents for this astronomy. Okay, and then we just want this fine, which I'm just going to erase this. They said the fine was $8.70. So we're just going to solve for D here. Okay, so let's go ahead and simplify. So this is 8.7 equals 0.5D plus 0.7. Okay, subtract 0.7 on both sides, so 8 equals 0.5D. Okay, Keep solving for D, so we'll divide by 0.5. You should get D equals 16. Okay, so he's got the 4 books for 16 days, and then the astronomy book would be 16 plus 7, so 23 days. Okay, so don't forget, it says how long was each book overdue. So the 4 books that he checked out on the same day were overdue for 16 days, the astronomy for 23, because that was plus 7 here. Okay, so that concludes the heart of algebra. A lot of your SAT exam comes from this set. Okay, so make sure you really understand it. If you have any questions, please email me or call me. You can now complete practice set 2, which is a pretty large practice set. It's mostly over linear functions and graphing linear functions, looking at slopes and y-intercepts, and then we go into inequalities and graphing and solving systems. And then you also have some word problems on that. So go ahead and complete practice set 2.